number 67, what volume of a 0.20 molar potassium sulfate solution, K2SO4, contains 57 grams of potassium sulfate? Okay, so they're asking for the volume here, right? And they gave us a molarity and they gave us a quantity, right? They gave us a mass. Gram is a mass value. Now, I'm trying to find out the volume. So there's either two ways that we could go about this. We could try to go back to the original molarity formula, but that one says molarity equals. So I'm going to give you a diagram in which you could solve for different things. It will help you out with making your formula to solve for different things. And that's this diagram right here. Now, yours doesn't have to be as colorful as mine. The point just has to get across that you need a triangle, and you need to put a T in the middle, and then the units, and the only three units that are allowed in this triangle, if we're doing molarity, is molarity on the bottom left, the number of moles on the top, and the liters on the bottom right. Now in this case, we're asking for what's the volume. Out of these three, the volume is the liters, right? So really they're asking for what is the liters. So that's what I'm searching for. So I should make a formula in which it's liters equals something. Now, how do I make that formula? Well, what you're going to do is whatever the unit that you're searching for, in this case it's liters, you're going to hover over it with your thumb. Now, when you hover over it with your thumb, technically it shouldn't be there anymore, right? If you guys have this on paper. So I'm going to hover over my liter. It's not there anymore. And now the only units left are mole on the top and molarity on the bottom. Since mole is on the top and there's this little symbol here and molarity is on the bottom, what do you think this represents? That's a division sign. So technically liters equal mole divided by molarity. And there is the formula that you need. I'm just going to put this over here. Okay, so let's see. Do I have a mole value and do I have a molarity? Well, they gave us a molarity, right? Capital M is molarity, so I know the bottom number, 0.20. But did they give me a mole? No, they gave me a gram value, right? They gave me a mass. So before I find out my volume, I have to first convert. I have to convert 57 grams of K2SO4 into moles of K2SO4. So we could do that by either doing dimensional analysis, or we could do this little quick trick that I'm going to do at the bottom. We're not in dimensional analysis mode anymore, right? That was so like chapter 1 or chapter 2 or test 1. So we can do like these quick tricks to just make converting easier. If you're starting off with grams, which is what we have here, right, and it's grams of any element or compound, I label that as X, and you want to go to the moles of the same compound, so X goes with X, and in this case, that's what we have, right? We have grams of the potassium sulfate, and I just want to find the moles of potassium sulfate. It's the same compound. So all I got to do is I just got to take those grams, and if I'm going this way, I have to divide by the molar weight, aka the molar mass. Where do I find this number, guys, though? They didn't tell me. It comes from the periodic table. It's on the PT. So I first have to find out what the molecular weight is of K2SO4. So we've done tons of problems finding the molecular weight, right? This is going back to previous chapters. So just make sure that when you're doing your mass, you have 2 potassiums, 1 sulfur, and 4 oxygens, right? And you just multiply them by the weights respectively. I'm going to get the exact answer on my periodic table. You can round your numbers. Let's see if we come out with the same number. I'm just going to do it quickly for you guys. So we got 2 potassiums. Each potassium weighs roughly 39. I got a sulfur, and then I got 4 oxygens. Right? Yep, there's only 3 elements here. So the molecular weight is 174.26, and that's grams per mole. Okay, now we're ready to do the conversion. I'm going to take the grams that I have, the 57, and divide by the the weight that I just found out to get the moles. So let's do it. 57 grams divided by the weight that I just found out, 174.26, and that's grams per mole. And look what happened. Grams on the top, grams on the bottom. That's why mole is just the leftover unit. So that's why this little trick works. So let's see, 57 divided by that molar mass. I got 2 sig figs, so 0.33. And now that's in moles of K2SO4. I finally found out what that top number was supposed to be, 0.33 moles. So now I can finally find out what my liters are going to be, right? L for liters. So liters is 0.33 moles divided by the 0.20. Let's see, what do we got? 0.33 divided by 0.2. Technically 2 sig figs here, so it should be 1.7. And the unit, the volume, is liters. So I should only have 1.7 liters of this solution that contain the 57 grams. And that's it. So guys, just remember this chart. It will help you along the way. You could also use this chart for density. It's a triangle, and then it's DMV. The DMV, the best place to be. So you could use it for molarity, or you could use it for density. So there you go, guys. Hopefully this helped. Click the subscribe button if you can. That will help us out. And I thank you from the bottom of my heart. You guys rock. Love doing these videos for you guys. I really want you guys to succeed. And yeah, that's all I got. Love you guys. I will see you in the next video. Bye-bye.